Chapter 5,
Practice test.
5D process,
All the rest.
percent and probability. We'll make a table,
We'll make a tree.
If that is not enough for you, there's
Unequal sample spaces too.
So come on now, here we go. I'll show you how to do it. All right, hello. It is me, Mr. Barbera, here to do the Chapter 5 practice test. I'm going to keep a little scratch paper here because I might want to show you a couple different approaches for some of these problems. Let's start with standard 1. I don't know, for whatever reason I have the camera out. You can see my foot over here, so hello. Mr. Goldman bought a new porcelain doll of himself at a 20% off sale and saved $12. What was the regular price of the doll? So we give you a diagram here, right? So I'm trying to help you with the line diagram. We can see that the $12 is 20%. So $12 is 20%. I'm going to use a ratio here to show that. There are a lot of different ways we can solve this, and in class we've seen a few different ones. I want to talk about two approaches here. So one approach I see a lot of students doing is bringing this down to 10%. So if $12 is 20%, I can divide both of these by 2. Because this is a proportional relationship here between the price and the percent. And that'll show me that $6 is equivalent to 10%. And then I can continue that pattern so I can build from there. If I want to know what 100% is, which is really what the question was getting at, I can multiply 10% by, I'm going to use the dot for multiplication, times 10. And I have to do the same here with $6. And that would show me that $60 is 100%. So ultimately, that's what the question's looking for. Oh, and also, we already knew this is 20% off. And then from there, you could figure it out. So you could go, okay, if $60 is 100%, I take away $12, and I'm left with $48. And I can use a similar strategy over here for the percent, where if this is 100%, I take away 20%, and I'm left with 80%. Now, another strategy that I saw, and I'm going to go ahead and use a different notation for the ratio here. I'm going to write it like a fraction just to show that both work. I saw people go directly to 80% or 100% from here. So if we know that 20% goes into 80% 4 times, I can multiply by 4 over 4 and go straight to $48 is 80%. And similarly, if I know that 20% goes into 100% 5 times, I could do 12 over 20 times 5 over 5 and see that $60 will be 100%. So a couple different strategies there. Moving down to letter B. It says, Mr. Barbera reduced the price of his sweaters knit from hair he found at the park by $18. I don't really do this. I just thought it was funny and gross. So if this represents a 30% decrease, how much did the sweaters originally cost? So we know that the $18 is a 30% decrease. Again, the total cost would be 100%. So 70% is this chunk over here. And we're taking away $18. A lot of different strategies. I'm going to go ahead and just talk about one this time. So if $18 is 30%, what I saw most students doing in class was dividing both of these by 3. Well, why do we divide these by 3? Well, if we divide 30% by 3, we're going to get 10%. And that would be $6. And that helps me because it's a lot easier to build anything else up here or over here out of 10%. So now if I want to know what 100% of the cost is, again, I multiply 10 by 10. And it just so happens that this one is also $60 for 100%. That was not an accident, but it wasn't intentional. I didn't mean for them to have the same overall price. And then we can do the same thing down here to find 70%. I can have 6 over 10%, multiply by 7 over 7, and I'd get 42 over 100%. So this is $42. And that is standard 1. All right, standard 2, probability. So remember probability at its simplest, we are dividing our desired outcomes meaning what do I want? What am I looking for? And I'm dividing it by the total number of outcomes. What are all the possible things that could result from doing this task? So if I'm rolling a prime number on a standard number cube, remember that prime numbers are those numbers which are only divisible by 1 and themselves. And they also cannot be 1, which is something I always have a hard time remembering, but we have to remember that. So 2, 3, and 5 are my prime numbers. A standard number cube has 6 sides, so that would be 3 out of 6. I'm looking at 3 prime numbers at a 6 total, and I could also reduce that to 1/2. Now, when I want to write that as a percent, remember I told you can use your calculators on Friday, but I will show it to you by hand here. So if I divide 1 divided by 2, because remember this is a division problem, I put a decimal point because 2 doesn't go into 1, a 0. 2 goes into 10 5 times, and that is an exact division problem. So I have 0.5. To go from a decimal to a percent, I multiply by 100. So that brings this twice. I put a 0, so it is 50%. I know my work's a little messy here, but hopefully you followed the idea. Let's keep with that same theme here. I want a probability of getting a red marble from 120 marbles if 45 of them are red. My desired is the red that I want. So 45 divided by 120. And when I divide 45 by 120, I can actually simplify this by dividing both by 15. And that is 3 over, and I'm blanking on 15 goes into 120 8 times. Now, I don't feel like showing you all the long division on this one, I'll be honest. So we'll use a calculator here. We're going to go 3 divided by 8. And that's 0.375, which is my decimal form. I'm going to multiply that by 100 to make it a percent. And that would be 37.5%. The third one here, drawing an even number diamond from a standard deck of cards. Remember, if you don't remember a deck of cards, I will put a picture up in class. And if you have Ms. Shaw or Mr. Goldman, I'm sure they will show you an image of a deck of cards too. There's 52 cards total. And if we think about the diamonds, there's 13 diamonds. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. But we're only looking for the even number diamonds. So that would be 2, 4, 6, 8, 10. That's 1, 2, 3, 4, 5 cards out of 52. And again, I'll go ahead and do the division of my calculator here. 5 divided by 52. It's a big ugly decimal, so I'm just going to round it off right here. And so it's going to be 0.096. Multiply that by 100. And that's 9.6%. And that is standard 2. All right, standard 3. If I had you in the afternoon, I mentioned that I get nervous about this one. I think this one could be tough for students. Remember, though, the beauty of our system is that if you don't get it this week, I think that you can take retakes. Not I think. You can take retakes. So we're learning at our own pace. If we're not there right now, not a big deal. You'll make it. Just get the help you need, put in the work, and you're going to do great. So a spinner has 4 unequal sections. The red is 3/8, the blue is 1/4, and the green is 5/16. Now, the thing we need to know here is that the total spinner has to add up to 1 whole. Because that's all the possibilities. 100% of our spins is going to be one of those 4 colors. So I'm not going to draw this to scale, but if the red was 3/8. I really did draw that like the blue though. The blue was 1/4. And then the green is 5/16. We're looking for what this extra part is. It's actually, in reality, going to be a lot smaller than that. So to do that, I like to figure out what all these parts are first and then subtract them from the total, the 1 whole. Oops, excuse me. So 3/8 is, if I multiply that by 2/2, that would be 6/16. And 1/4, if I multiply that by 4/4, it's going to be 4/16. And 5/16, I don't have to do anything with. So I'm going to add those all up. 6/16 plus 4/16. I'm getting text. I don't know if you can hear the pinging in the background. I apologize. Plus 5/16. And that comes out to 15 over 16. Some of you may already be ahead of me, but we're going to take that away from 1 whole, or 16 over 16. And that does come out to 1/16. So the probability of getting turquoise is 1/16. So like I said, this would actually be a much smaller section in the end. And then the next one, what is the probability that on any turn you will not get red? That is called the complement of red. So if the probability of red is 3/8, not getting red is everything else to get to 1. So again, I'm going to start with 8 over 8. That's 1. I'm going to subtract the 3/8, and I can see that 5/8 is the probability of not getting red. On we go to standard 4.